Okay, so today we're going to learn about the importance of creating a sustainable future, alternative sustainable designs that already exist, and we're going to explore future designs, have a little bit of a brainstorm, and begin designing our future farms using Tinkercad. Sustainable agriculture is a type of agriculture that focuses on producing long-term crops and livestock while having minimal effects on the environment. So sustainable agriculture really focuses on minimizing our impact and our global carbon footprint. Sustainable agriculture also focuses on maintaining economic stability in farms and helping farmers improve their techniques to improve their quality of life. And you can see in the picture that we're really just trying to minimize our global footprint, so minimizing our impact on the world. So in previous lessons, we talked about there's an orangutan in my bedroom, and we talked about the example of how due to habitat loss, over 70% of the orangutan population in Brazil has depleted in numbers, and that was due to the overproduction of palm oil. Now, we use palm oil in many things. We use palm oil in our shampoos, in our food, in our cleaning products. So palm oil is very much a part of our daily lives, and it's something that has caused a massive biodiversity loss in that orangutan population. So there are other problems with current practices. So as an example, we have our current irrigation systems, and the flow of the irrigation system and the movement into our groundwater basically produces all the chemicals from the groundwater. And we have what is called a nutrient runoff. So we were talking about nutrient runoffs in phosphates and nitrates, and they run off into local streams and they flow through into our reef. And we were talking about as well the crown of thorns starfish proliferation due to an increase in the nutrient buildup and the bleaching of coral over time. So we talked about that in previous lessons as well. So I've asked you to watch the video at home, preserve the wonder, and answer the questions below in your OneNote. So the questions, will go through them together. So what do farmers need to think about? So farmers really need to think about how they're going to manage their property, so their inputs versus their outputs. And you'll see here that they've got to think about soil salinity management, energy management, nutrient and soil and fertility management, pest management, which Mr. Ang was talking about, using parasitoids to manage pests, pasture land management, we've got livestock management, erosion management, very important for our waterways, water and irrigation management, and fishery and aquaculture management, and wetlands management. So there's a lot of things that we have to manage as farmers when we think about our future. So over the decades of scientific practice, several key farming principles have been introduced to increase the sustainability of our farms. So an example is rotating crops and embracing diversity. So we've heard all about rotating crops. So plants of a variety of crops can have many benefits, which include healthier soil and improved pest control. So intercropping is a way that you can do this. So growing a mix of crops in the same area and having complex multi-year crop rotation. So continuously rotating your crops over time. You can plant overcrops, so cover crops like clover, or in this case on the right hand side. So just here you'll see what is called hairy vetch. So these plants are planted in during the off-season when soils might be left bare, and these crops protect and build our soil health, and they prevent erosion, replenish soil nutrients, and basically keep our weeds in check. And they reduce the need for herbicide, which was very important. So we talked about that in our first lesson, about the importance of herbicide elimination. They also reduce and eliminate tillage. So traditional ploughing methods, which is called tillage, prepares the field for planting and prevents weed problems, but it causes serious loss in soil. And no-till or reduced-till methods, which involve just simply inserting the seed directly into the soil, can reduce erosion and improve soil health. We can apply integrated pest management systems, so like Mr. Guriang was talking about, so a range of methods which include mechanical and biological controls. So biological, in our second lesson, we were talking about introducing a genome into the plants to control pest management, or we can also introduce the wasps, like the parasitoids, to manage those pests that affect our crops and our plants. So they can be applied systematically, and they keep pest populations under control while minimizing the use of chemical pesticides. We can also integrate livestock and crops. So industrial agriculture tends to keep plants and animal production separate, and the animals generally live in a faraway area from where the plants are produced. So there's a growing body of evidence that shows that if you smartly integrate the plant and animal production together, you actually have a more efficient, profitable farm. So an example is using the manure as fertilizers for the plants. We can also adopt agroforestry practices. So by mixing in trees and shrubs, farmers can then provide shelter and protection to their plants, animals, and water resources. And it also offers additional income as well. So we're working together with that agroforestry minister. And then finally, looking at managing whole land landscapes. So sustainable farms treat uncultivated or less intensely cultivated areas such as riparian buffers or prairie strips as integral to the farm. We need to value these for our controlling erosion and reducing nutrient runoff, but it also supports pollinators and offers an increase in biodiversity. So it doesn't necessarily mean we have to choose the environment over profit. Some people think that that is choosing the environment over profit. Not necessarily if we manage the design of our farms well. So here's an example of current architecture with environmentally sustainability in mind when they built it. So on the left, you'll see a high-rise that's been made in Shenzhen, China. So the Shenzhen, China high-rise. So if you look at this one here, the Shenzhen high-rise in China actually uses a complex mechanism that works around solar and wind management. So the wind will pass through the corridors that it is attached to the high-rise, and the solar implemented off of the glass also contributes to the farming community within that high-rise. You also have on the right-hand side, you'll also see the Singapore Gardens. So the Singapore Gardens were an initiative created by the government of Singapore to increase sustainability and environmental awareness in their city. So we'll go through a little bit about how both of these work. Okay, so I'm just going to zoom in here. Okay, so just at the top of this picture, so let me see if I can get my pen and draw on it. So you'll see that the sun is coming into our solar, so our solar panels just here. And then the solar panels are producing energy, and the energy moves down through some thermal heated vents. And then the thermal heated vents will come up and be powered. So they'll move through the building and they'll heat. So they'll apply heat underneath for when the plants need heat at night. You'll see that the rainwater comes down and moves in a complex chain. So let me do blue throughout the building. So it'll move down and it'll go throughout the building and power all, so supply to plants all through the building, inside and outside. And there's also one more thing that it's got, which is the complex airflow mechanisms. So we're talking about the airflow, so it's actually providing the oxygen that all these plants need, as well as providing some air energy that powers through the building. So you can see that it has an open, aerated building moving in and out of the building. And that's keeping that airflow movement, and it's preventing bacteria buildup. This also takes into account, so we've got the blue here for the rain. This also takes into account the movement of the sun during winter and during summer. So the actual outline of the building has been created specifically to cater for all of those needs for the plants. The second one that we're looking at is a schematic diagram for the symbiotic relationship that the gardens have. Let me just zoom out here because my crop does not want to work. So over here, out, thank you, lovely, eraser, please don't mind my picture, it just does not want to work for me today. Okay, so what you can't see on the left hand side is that you'll see underground thermal vents, so that red line running across is the underground thermal vents. And those thermal vents are powered by solar panels. Stop it already. Are powered by solar panels on the top. Let me just do that. So solar panels on the top. And the solar power is moving through and generating power for not only burning off, so getting some energy there from the foliage runoff, but it's also powering a generator that is moving the water through the gardens. Oh. Sorry, Ali. Apparently it just does not want to work for me today. Okay, let's see if you can follow along with me still. Maybe 1 second. All the way down. Okay. So you have the biodegradable waste down the bottom, so the biodegradable waste moving across landfill and then being reused again, and then powering and using some water underneath there. You then have a very complex irrigation system that they have used to not only power the biodegradable waste buildup and the electricity that the gardens use, but it has also provided rainwater to different areas, and it comes out and it's cleaned to be removed into their natural system. So I'll provide you with a better picture in the future and we can go through that together. So an example of a structure that's already been built in this manner is a wooden house in Sao Paulo, Brazil. So the wooden house has on every level a garden integrated into it, and it's highlighting the need for sustainable living, not only just as a farmer, but as a member of a community. So they have a complex irrigation system again, which goes through, and they have solar panels up the top, and that will be used to power that the energy used in that building. So ARPA had a good question about how the wood does not stay mouldy because it's made entirely out of wood. I'd like you to go off and research that for me. There are another two, so these are future. So when we're looking into the future, we have vertical farming. So on the left-hand side, you'll see a design for so let me just zoom that out. So on this side, we have a design for a vertical farm within a city. So you can see it's only taking up a certain amount of land. It has different levels, which is integrated into the system. And it also has a high-rise building, so people working there as a community to power that plant. On the other side, so on the right-hand side, so there's an idea. On the right-hand side, we have another vertical farm, but this time it's in Singapore, and they've decided that they're going to place it in the Singapore Bay, so just on the water, and it's going to be using a water generator to power that plant. So we had a little bit of a discussion about which one we would choose. So some of us chose the vertical farming on water, and some of us chose the farm in the middle of a city, but in this case, the difference really is in the amount of space and the amount of money and costs that are involved, we decided. We also looked at a community farming practice. So community farming has become a really big trend in Asia and also in England and America. So that is where the community builds its own farm. So a large community such as this one in Shenzhen in China, they've utilized all of the community to create a farm that is self-sustaining. So in this case, they used hydroponics to power that farm, and the people in the community maintain that farm over time. So we discussed some of the pros and cons. Some of the pros might be bringing the community together to work towards a common goal of sustainability. The negatives might be if you have a very small community, it might not be necessary, or you live in a farming community and therefore it is again not necessary. The other one we looked at is aquaponics. So aquaponics is just basically a floating farm. So you'll have seawater, so the seawater will be pumped through up into an irrigation system where the water nutrients will be moved into a freshwater tank. So they'll have the separation between the salt and the water, and then they'll be moved into the freshwater tank, and the freshwater tank will bring up the water throughout the farm, so it'll go in a zigzag pattern, and then it'll come back out again, and they'll be moved through the tank and then back out into the ocean. So you'll have the rainwater coming down, being collected as well, and that will also be used in our farms. So there's a few things to look at in that diagram. So have a look through and then see if you can identify the different parts and the different areas of the diagram. And then we asked, what about in the year 2050? So in the year 2050, we would like to be at least on our way to Mars. So on the left-hand side, you'll see an aquaponics farm that an artist has created a rendition of. But on the right, you'll see a farm that's already taking place that's very similar to what they're suggesting. So that is a hydroponics farm instead of aquaponics, and it's being monitored underground. and it takes up very minimal space because it's vertical again rather than horizontal. So you'll see the scientists there, and they're monitoring all of the saplings as they grow. So all of these farms have what we call design priorities. So they're built around priorities that they need to value. So number one, is it impactful? So does it help the community and the surrounding area? Two, is it well designed? So has it taken into consideration the life cycle costs or the costs involved in not only creating the farm but maintaining it and building it? Is it conducive to the environment? So does it inspire other scientists and other people to be creative and innovative in sustainability? And does it maximize its full environmental potential? So does your farm meet the needs of not only your plants but of the people that are living around your farm? So an example of this was, does it take into consideration the water cycle? So in the first one you saw that it took consideration into the water cycle. So we had the condensation, evaporation, precipitation, and then some of them took into account the surface flow and runoff and plant uptake and transpiration. So a lot of those were taking into account the water cycle. We have the oxygen cycle, where oxygen is placed into the atmosphere, and then we have respiration and decay from photolysis and weathering. The CO2 cycle, so where you have the decay of organisms, and then they move into root respiration and plant respiration, and uptake by the ocean. And also some of them took into account the nitrogen cycle. So we have nitrogen fixing bacteria, and then they'll move into the plants, and then the plants will decompose, and then you'll have denitrifying bacteria. So there's a few things that your future farms will need to take into account if they're to be sustainable. And finally, what we wanted to do is look at beginning the design of our future farms. Well, what would your future farm look like? So you'll need to begin designing your future farm by sketching your base design. We discussed our ideas as a group and brainstormed our future farms to see what different current farming practices we would like to use and what we can manipulate and change. So as an example, Angelina was looking at a floating farm, whereas Chloe was looking at a vertical farm. So there are some differences there. So everyone had their own ideas and what they found interesting. So it's up to you to go out and research and figure out what type of idea you would be interested in. So really we need to answer some of the following questions. So let's go past these ones. So question one, how could farmers design their farms to be more sustainable? What would a farm of the future look like? What kind of engineering would be involved and what do we use now? Who are the key stakeholders in your design? What would your future farm look like? And what parts do you need to sustain it? And how is your farm different to the farms that we have currently? In our tutorial session, we then, after we've sketched our ideas, we set up our Tinkercad account. So Tinkercad is an online system that allows you to build 3D models of your architectural designs. So we did our introductory tutorials on Tinkercad. So you need to use your school email and your password. So when I say school email, the start of your school email. So an example is mine, axlaw12, you're not adding in the eq.edu.au. And your password is science12. So on the top right side of your screen, you'll see the Learn button. You need to click on that. And then there are 7 lessons that you can use to create, move, and manipulate your 3D models. So Ali, for you, your task will be step 1, listening to this. Step 2, sketching out your base design for your farm. So doing some research on what type of future farm you would like to create. What you're going to actually harvest. So what is the food of the future that you wish to harvest? And then step 3 or 4, can't remember right now, but step 3 or 4, going into Tinkercad and then creating your 3D design. If you have any questions, please email me and I will get back to you on any of those questions. Okay, hopefully this helped, and I will talk to you soon.